Hi, today we're going to be talking about a startup company specializing in installing solar microgrids in a developing country, Sudan and Northeast Africa, and hence the name Solar Microgrids Company, Smyco for short, for sensible solar solutions. The next one we're going to be talking about the challenge in Sudan is that about 50% of the population doesn't have access to electricity. Add to that, the government itself cannot meet up the soaring demand for electricity, and add to that again also the outdated and inefficient national grid, which is marked with inefficiencies in high voltage transmission and distribution lines. Talking to the customer over here, the voice of the stakeholders, talking to different residential customers and even business owners, installers, and even government officials. The summary of that slide is that the government has a monopoly over electricity generation distribution, and they look at it as a cash cow. However, it is highly subsidized to keep the population happy. But they cannot meet the demand, and hence there is now a new direction in the government to change to allow for private citizens to produce their own power. So here is the situation in Sudan, being uniquely located in Northeast Africa as a sub-Saharan country with high soaring temperatures. The three main parameters that affects the efficiency of the generation conversion of the solar rays to electrical energy is the photovoltaic power potential, PV out, also the direct normal irradiation, DNI, and the global horizontal irradiation, GHI. As you could see, these numbers are very high over here. Now, the opportunity in Sudan arises from the fact that the electrical service is highly unreliable because of the scheduled cuts. The government cannot meet the high demand. So for residential, industrial, and agriculture, there is an opportunity, to provide solar power in there to subsidize the gap in the electrical service from the government. Also for the affluent power consumers that can afford to have a generator powered microgrid, there is also a potential opportunity there with expensive diesel fuel and also the unavailability of the fuel itself. And also the government, knowing its shortcoming, they are dropping the custom tariffs, for the solar panels and equipment coming from the outside the country. And also they're working on legislature for electricity buyback and credit system. Hence, the solution is Smyco, a small startup company installing solar microgrids for residential, industrial, and agricultural applications. And of course, a typical system will consist of rooftops, solar arrays, inverters, and batteries and power cables. So here is the Smyco ecosystem. As you could see, it's in the middle, in between its customers, residential and industrial customers, with a color-coded, arrows over here showing the flow of product, payment, and information, and also it shows the flow, interaction with its solar vendors and also financial institutions to subsidize the whole deal over here. And as you could see, also the interaction of the consumers with the national grid. Here is the Smyco business model, which revolves around the value proposition, which is Smyco is going to come in to augment the electrical energy supply from the national grid with renewable energy source, which is solar in this case, in a cost-effective manner, leading to gradually to complete independence and eventually becoming private producer. The key partners in this, of course, is going to be the solar and inverters and storage systems manufacturers as vendors and cable systems producers. Also, the revenue streams for this one is going to be the consultation fees, system design and integration fees, system installation and maintenance, and eventually, in the long run, maybe power trading negotiations. The analysis tool that is used in this one over here, we use the System Advisor model, SAM for short, which is a free techno-economic software model that facilitates the decision-making that's developed by the National Renewable Energy Lab and REL that can model PV systems, battery storage, wind power, marine energy, geothermal, and biomass combustion using financial metrics for residential and commercial projects, and also can model power purchase agreements as third-party ownership projects. Here is user case one for residential for a 3-story building with 3 households, extended family, with all the loads listed in here for light bulbs and TV sets, laptops, ceiling fans, and air conditioning units. The underlying assumption over here is that there is a scheduled power cuts certain hours of the day for the weekdays and also for the weekend. With that in mind, the calculated load average for the average hour for the peak and weekdays and weekends is listed over here. Now, running the SAM model for that, the PV system would consist of 12 modules supported by 5 kilowatt inverter. That would realize a net savings of close to $700 for year 1, increasing to $1,100 for year 25. This is in electrical bill savings. There is also the system is going to result in a positive MPV with a levelized cost of energy, a little bit more expensive than what they buy from the national grid. The payback period for this system is going to be a little bit shy of 10 years. Now, for user case 2, it's industrial case for a small packaging material factory with 80 workers, 2 work shifts, and 6 working days. Again, the assumptions for the power cuts from the national grids are listed over here for the weekdays and weekends. And taking that into consideration, the hourly average load for the peak and weekdays and weekends are listed here. Running the SAM model for that, it turns out like we need 96 modules for that, supported by a 44 kilowatt inverter. That's going to realize a net savings of close to $4,300 in year 1 in electric bill saving, increasing to $7,800 close to in year 25, with a net with a positive MPV and levelized cost of energy came out to be cheaper than what they buy from the national grid. The payback period on this system is 14.3 years. Now, here is the dashboard, which acts as a main interaction between the consumer and the system. It shows real-time the power generated from the solar panels or from this from the grid, and the difference between the two real-time. So, now, here is the assumptions for starting Smyco. We're going to start with 1 manager, and then we're going to keep adding 1 sales rep and 1 maintenance rep, after the first 6 months of operations, and then 1 of each every year. And also, we're going to assume that we're going to start with 3 customers to begin with, acquiring 3 customers per sales rep per month after 1 month of a grace period. Of course, the revenue streams is going to be selling solar packages to residential and commercial customers, and then selling maintenance packages to interested customers. If you look to the right-hand side in the graph over here, you're going to see the net income cash flow for Smyco, and you're going to see for the first 13 months, there is going to be a negative cash flow, but then after that, it's going to go positive all the way for the whole analysis period of 24 months and then beyond. Now, we're asking for the finance $65,000 seed money as convertible notes with a 20% discount for a $780,000 valuation cap. This is going to give us 12 months of runway. And if you look to the right-hand side in the graph over here, you could see the use of the proceeds for the initial company setup, marketing, working capital, and operations, money. I thank you very much for taking the time to listen to me, and all the feedbacks are welcome. I am Ahmed Mohammed, graduating Master of Engineering Management, Northwestern University. Thank you.